Welcome to lecture number 105 of digital electronics. Now, in the last lecture, that is in lecture number 104, we have dealt with data transmission in shift registers. We have dealt with serial input, serial output, how data is transferred, serial input, parallel output, how data is transferred, parallel input, serial output, how data is transferred there. Then parallel input and parallel output, how data is transferred, and we have also dealt with bidirectional shift registers, rotate right shift registers and rotate left shift registers. Now coming into logic circuit of shift registers. So first I am going to deal with serial input, serial output, shift register, that is SISO, serial input, serial output, shift register, that is SISO, shift register. Now, what is basically a shift register? Here, so many data are fed in and data are taken out. That means data is shifted from an input mode to an output mode. That is known as shift register. Now, let me explain the logic circuit of a serial input, serial output shift register. Generally, shift registers are formed based on D flip-flops. Okay. Because in D flip-flops, the specialty is that whatever is coming in as D, it will be the output in the subsequent clock pulse. That is the specialty of D flip-flop. Okay. Whatever is coming in as D, so we are having a D flip-flop. D, suppose if D is equal to 1 and making the clock as 1, you will get the output as Q is equal to D. If initially Q is equal to 0, then it will be made to Q is equal to 1. So that property of D flip-flop can be applied in shift registers. That means in one clock pulse itself we are getting the whatever is data input, we are taking the data output in one clock pulse itself. This property is very much required in shift registers. Now coming into serial input, serial output shift registers. Suppose I am having a 4-bit serial input, serial output shift registers. I should have 4 flip-flops. Okay. I should have 4 flip-flops. And clock is common to all these things. Clock is common. So let this be D1, D1, Q1, Q1 bar, D2, Q2, Q2 bar, D3, Q3, U3 bar, D4, Q4, Q4 bar. Now whatever is coming, say this is a serial input. And output of the first flip-flop is given as input to the next flip-flop, likewise. Okay. Now, here you are taking the output only from Q4. That means you are getting serial output. Now, let us check how it is functioning. Let the serial input be 1, 0, 1, 1. Now, initially 1 is fed in here. Initially 1 is coming in. Okay, that is this one is coming in. In the first clock burst, that 1 goes to here. Okay. Now, after the first clock pulse, this one is coming in. Okay. So what happens in the second clock pulse? What happens is that this one will be transmitted to here, and this one will come here. So you get that one here. In the third clock pulse, this 0 is coming in. So what happens? This one goes here. Now this one comes here, and this 0 comes here. In the next clock pulse, this one will come out. Okay. And in the next clock pulse, this one will come out. Okay, and in the next clockwise this 0 will come out, and at last this 1 will come out. Okay, so that is how serial input, serial output register is, serial input, serial output shift register is functioning. Okay, that means in each clockwise the output will be changed. Okay, so that is output will be changed, and from each output no separate lines are taken. Serial output is taken directly. Now if I am explaining it with the help of another example, if 101 only it is, if you are tough to understand. If I am taking the example of 1010, 1010, okay. So in the first clockwise, so initially 0 is coming in. Initially 0 is coming in. In the first clockwise, 0 will go here. Okay. At that time, what happens? This 1 is coming as input here. Okay. And in the second clockwise, what happens is that 0 will go here, and this 1 will come here. 1 will, instead of 0 you will get 1. In the third clockwise, again the third 0 is coming in. In the third clockwise, the third 0 is coming in. Okay. So in that situation what happens? In the third clockwise, this 0 will be shifted to right, and this 1 will come here, and this 0 will be shifted to here. That is happening in the third clockwise. In the fourth clockwise, what you are getting? In the fourth clockwise, what you are going to do is you are giving 1 as input. Okay, giving 1 as input. So what happens? That 1 comes here instead of this 0, and this 0 will go in here. Okay, and here 1 was there. That 1 will go here, and this 0 will go as output. Now in another 4 clockwise, you will get 0 is coming out first, then comes 1. In the next clockwise, you will get 0. After that, you will get 1. So this is how a serial input, serial output shift register is functioning. Okay. So that is regarding serial input, serial output shift register. Next one is, only difference is in the next one, the only difference is we are taking the outputs in parallel. Operation is pretty much similar, but only thing is, instead of taking the serial outputs, we are taking bit by bit outputs separately. So next one is serial input, parallel output shift registers. Serial input, parallel output shift registers. That is SIPO. Serial input, parallel output shift registers. Okay. Now if I am drawing it with the help of a D flip-flop, I am having a clock 1, 2, 3, 4. Clock is common. So this clock is common. Here also clock is common. So here you have D1, Q1, Q1 bar, D2, Q2, Q2 bar, D3, Q3, U3 bar, D4, Q4, Q4 bar. Here the only difference is data is coming in here. This will be transferred to D2, Q2 will be transferred to D3, Q3 will be transferred to D4, and Q4 is taken out. This is Q4. But you can take your data separately. Here you are having Q3, here you are having Q2, here you are having Q1. Now for example, if I am giving the data in as 1, 0, 1, 0, that is easy to remember. Okay. In the first clockwise, 0 will come here. So that 0 is coming here. In the second clockwise, this 0 will be shifted as Q2, and you will get 1 here. In the third clockwise, 0 will be shifted here, you will get 1 here, and next 0 will come in here. and in fourth clockwise you will get 0, 1, 0, 1. So these are the parallel outputs in 4 clockwise. Okay. So you are having, this is first clockwise, second clockwise, third clockwise and fourth clockwise. So in 4 clockwise you are getting the output. Whereas here you need to, here to get the entire output you need to wait for 8 clockwise. Because we are having 4 flip-flops, you need to wait for 8 clockwise to get the proper output, or to get the serial output. So here what is the specialty is that serial input, serial output, shift register is providing a time delay. Whereas in serial input, parallel output, shift register, there is also a time delay, but that time delay is reduced to 4 clock pulses. Now I will explain parallel input, parallel output, shift register. After that I will discuss about parallel input, serial output, shift register. Now coming into parallel input, parallel input, parallel output, shift register. Parallel input, parallel output, shift registers, that is PIPO shift registers. So here what happens? Let me check. Okay. Here data is fed in parallelly and output is also taken parallelly. That is the only difference. So suppose I am having 4 bits. That means I should have 4 flip-flops. 1, 2, 3, 4. So here in D1, Q1, Q1 bar, D2, Q2, Q2 bar, D3, Q3, Q3 bar, D4, Q4, Q4 bar. Okay. And clock is common. Common clock. Okay. Now input is coming from here. That is parallel input. We are having parallel inputs. That is, this is D1, D2, D3, D4. We are having parallel inputs, and outputs are also taken parallelly. Q1, Q2, Q3, Q4. Outputs are also parallel. So what happens is that if I am giving you the data like 1, 1, 1, 0, 0. For example, if I am giving the data like that, in the first clockwise itself, you will get this one will be coming out as here, this one will be coming out here, this 0 will be coming out as 0 here, this 0 will be coming out as 0 here. So here in parallel input, parallel output shift register, only thing is you are providing a delay of 1 clockwise. Providing a delay of 1 clockwise. In the first clockwise itself, you are getting the output. So that is the basic operation of parallel input, parallel output, shift registers. Now coming into operation of parallel input, serial output, shift register. Parallel input, serial output, shift register, that is PISO. Parallel input, serial output, shift register. Okay. So here there are 2 operations. Input is parallel, as well as the output needs to be fed in serially to the next flip-flop. Okay. So coming in to that. Okay. So I am having 4 flip-flops. Okay. 3, 4. Okay. Now see here what I am going to do is I am going to give parallel inputs. D1, D2, D3, D4. A is an input. Here. Okay, A is an input here. Now, B cannot be given directly. Okay, B cannot be given directly. So, what I am going to do is, we are having a shift bar, load bar. Okay, so I am taking that connection here, shift bar, load bar. Okay, and I am taking complement of that also. I am taking the complement of, this is the complement of that, and this I am taking directly for the time being. Okay. Now A is fed in. Say here you are having Q1, Q1 bar, Q2, Q2 bar, Q3, Q3 bar, Q4, Q4 bar. Okay. The clock is common. Okay. Having common clock. Okay, clock is common. Now, the first bit, that is A, is fed in directly. Whereas, when you are coming into B, there is a problem. You cannot fed in B directly, because there is one chance that this needs to be this Q1 needs to be transferred to D2, as well as B needs to be transferred to D2. Okay, there are two things. Q1 can be transferred to D2, as well as B can be transferred to D2. Similarly, in the case of C, Q2 needs to be transferred to D3, as well as C needs to be transferred to D3. Two possibilities are there. Here, if I am feeding in D, here also there are two possibilities. What is it? Q3 needs to be in serial output, Q3 needs to be transferred to D4, and in parallel input, D needs to be fed into D4. So there should be a mode selector. Here there should be a mode selector between B and Q1. Here there should be a mode selector between C and Q2. Here there should be a mode selector between D and Q3. Okay. Now how that mode selector is being done? So here I am having a gate. Okay. So Q1 is fed to this gate. Okay. And if it is shift, okay, if shift is high, we should come here. So I am taking this as gate 1. If shift is high, this Q1 should come in. Okay. And if shift is low, that means no need to shift. That means Q1 need not be shifted to D2. At that time, B should be coming. So what happens? So in that case, I am having B as input and no shift as input. Okay. And these two things needs to be ORed and given to D2. Now see here what happens. When shift is equal to 0. Okay. When shift is equal to 0, this is 1. So what happens? B dot 1 comes in. Whereas the output of gate 1 will be equal to 0. Okay. Whereas if we need to load it, if I am making shift as 1, what happens? Here you will get 0. That means the B will not go in. Only Q1 dot 1 will be going in. Hope you have got the point. That means here I am having two AND gates, one OR gate. That means either the output of G1 or the output of G2. Now if I am taking the output of G1, then this bit should be 1. That means if shift is 1, if this bit is shift is 1, what happens is that you will get Q1 dot 1. So Q1 will be going into D2. Whereas if shift is 0, what happens? The output of G1 will be 0, and output of if shift is 0, the output of G1 will be 0, whereas the output of G2 will be B dot 1. So B will be going into D2. Similarly, here you should have two gates. You should have G3 and G4. For G4, one of the inputs should be C AND gate. So here you have G3. For shifting, you should have this operation, and for loading, you should have this operation coming in. And you have to OR these two. two, or these two, and it should be going into D3. Similarly, you should get G6 here. This is G6. This is coming in from here, and you should have G5, and Q3 will be going into G5. 1 second, I'll just write. This is G5. Q3 will be going into G5. Here also it is coming, and the output of G5 and G6, that is an OR gate. That OR gate will come into D4, and we are taking all the outputs. That is, this is only Q4 is taken out. That means here what happens is that when shift is equal to 1, say this is gate A or gate GA, GB, GC. Okay, the output of gate A will be, when shift is equal to 1, what happens? You will get 1.Q1 or 0.B. So what happens? You will get Q1. That means when shift is equal to 1, the output of gate A will be Q1. That means Q1 will be fed in as D2. And similarly, GB is equal to 1.Q2 or 0.C. So that is equal to Q2. GC, what is GC? GC is Q3.1, 1.Q3 or D.0. So what will you get? You will get Q3 as output. Okay. So in these three, when shift is equal to 1, what happens? Q1 is fed as D2, Q2 is fed as D3, and Q3 is fed as D4. Whereas when shift is equal to 0, what is output of gate A? Output of gate A will be B.1. Sorry, you can write as 0.Q1 or 1.B. So B will go in as input. What is output of gate B? You will get 0.Q2 or 1.C. What is it? You will get C. What is the output of gate C? You will get 0.Q3 or 1.D. What is it? D. That means when shift is equal to 0, it works in parallel input mode, whereas parallel input serial output mode. Whereas when shift is equal to 1, it works in when shift is equal to 0, it will work in parallel input mode, and when shift is equal to 1, it will work in serial output mode. So here what happens is that initially shift is made to 0. So that B, C and D are fed in as D2. Sorry, ABCD. ABCD are fed in as D1, D2, D3 and D4. After that what happens? Shift is made to 1. So what happens? In the next clockwise, Q1 will go in as D2, Q2 will go in as D3, and Q3 will go in as D4. So that is basically the operation of parallel input, serial output, shift register. Okay. So here there is a mode selector. The mode selector is between what? Whether you need parallel input or whether you need serial output. So initially you have to make shift is equal to 0 so that A, B, C and D are coming in. Then you make it into next mode, that is serial output. So there are two modes of operation for it. One is for parallel input mode and another is for serial output mode. So that is the basic operation of parallel input, serial output, shift registers. Okay. So I think you have got the concept of parallel input, serial output, shift registers. Now, in the next lecture, we'll be dealing with some counters based on these shift registers. Okay, we'll have two types of shift register counters, that is a ring counter and Johnson counter. How to design this ring counter and Johnson counter based on any of these shift registers, that we will deal it in the next lecture. Okay, so in this lecture it was dealt with what we are dealing with shift registers. We have dealt with the operation of serial input, serial output shift register, serial input, parallel output shift register, then parallel input, parallel output shift register, and parallel input, serial output shift registers. Thank you.